Good morning. It's glad to be here to deliver a speech related to blockchain. I'm Wang Xu from Tsinghua University. Today, my topic is framework and algorithm of honest blocks identification in blockchain. Here is the outline of my topic. It contains 4 parts. The first part is related to the brief introduction about the block DAG technology. The second part is about the core problem in block DAG technology. The third part is the honest blocks identification problem. It's the significant part of the report. The first part is about the conclusions. Now let's come to the first part, the brief introduction about the block DAG technology. Blockchain can trace back to 2009. It's originated from Bitcoin. Its essence is a decentralized and distributed database built by all parties for interest. There's a very popular and possible triangle in blockchain technology. In the triangle, there is efficiency, security, and decentralization. Nowadays, blockchain faces a very serious performance bottleneck. For example, Bitcoin can only deal with 6 to 7 transactions per second. As for Visa, it can deal with 50,000 transactions per second at peak. Alipay can deal with more than transactions than that. As for the impossible triangle, Bitcoin keeps its security and decentralization at the sacrifice of efficiency. In order to overcome the efficiency, lots of researchers are doing some research. For example, Ghost was proposed. Ghost made 4 use of the verification blocks, but these blocks only for the security. The information in these blocks are not used to improve the efficiency. After that, the directed acyclic graph from graph theory was introduced to blockchain. After the introduction of DAG for short, the block can link to more than 1 blocks. Here is an illustration of block DAG. You can see the block can link to more than 1 ascent blocks. Here comes the core problem in block DAG technology. Here is another illustration of block DAG. We have to point that there is no main chain in block DAG. But if there are 2 conflict transactions, it's hard to determine which one is effect. Here comes the core problem in block DAG, how to determine the total ordering of blocks in block DAG. We decompose the problem into 2 parts. The first problem is about the identification of honest blocks. The second part is the block sorting problem based on the identification results. Among the 2 problems, the efficiency, the first problem plays a key role in the solution of the second problem. In this report, we focus on the first problem, the identification of honest blocks. Now let's talk about the honest block identification problem in detail. In order to solve the problem, we introduce a definition named discard. It can be defined in any 2 blocks. The discard between 2 blocks can be defined as the length of the loop composed of the nearest common ancestor block and the nearest common descendant block. If there is no common descendant block between 2 blocks, a virtual block can be introduced. We give an illustration to help you to understand the definition. For example, for blocks, the discard between blocks A and B is 6. That's the number of blue lines in the figure. We introduce a virtual block V. As for blocks A and D, the discard between them is 4. Discard can be used to measure the probability that 2 blocks belong to different belong to different types. Through research, we found that the discord between the honest block is quite small, but as for the discord between the honest block and the dishonest block is quite large, so we can use this method to identify the honest blocks. We also gave out the discord, the mathematical formula for the discord between two blocks. I have mentioned just now that the discord between honest block is quite small, while the discord between the dishonest block and the honest block is quite large. So after introduction of the discord and the proper threshold, we can transform the DAG into undirected graph. In the undirected graph, there are more honest blocks in it, and the degree of the honest blocks is quite small. So the identification of honest block can be transformed into the maximum K independent set. Here the maximum K independent set is try to find the largest number of independent sets in which the largest degree is not is smaller than K. There are two parameters in the framework. If when K and D both takes to 0, the framework corresponds to the rule of largest chain. But only K takes 0, it corresponds to the popular property called phi. Because phi does not fit follows of the information between the blocks. Here we mainly focus on the other limitation side in which K takes 0. Next, we propose 3 algorithms for the max called 0D. Here, the maximum K independent set would be transformed to maximum independent set. We propose 3 algorithms for the max called 0D. The first algorithm is max called exact. Here, the maximum independent set is solved by accurate algorithm. Max called greedy. Here we use the greedy algorithm to solve the maximum independent set. The third algorithm is a heuristic algorithm. By solving a series of max called 0s, some suspicious attack blocks are filtered out. Starting from a relatively large S, max called RFA applies accurate algorithm for solving the maximum independent set to solve max called 0s and removes the attack blocks. Then we find the alpha quantile of the discords of the remaining blocks to continue reduce the value of S, solve the max called 0s on the remaining blocks. This continues until S reaches the preset threshold. Actually, the heuristic algorithm is quite similar to making sculptures. First, we sculpture the basic side, then we make some detailed correction. Next, we talk about the parameters determination. The first parameter is D. We found through the simulated block digit data, most of the discords between honest block would be less than 10, and the discord between honest blocks and attack blocks would be much larger than that. So in this research, we take H as the default value of D to identify the honest blocks. Here is a figure. The horizon vertex, the horizon axis represents the block generation rate. The vertical axis represents the maximum of honest blocks discords. So next we talk about another parameter alpha. Alpha needs to be selected not to ensure the D-discord graph constructed in each iteration is as sparse as possible. so that it can be solved by the accurate algorithm of maximum independent set, but also to make a trade-off between the number of steps required by the iteration algorithm and the time required for each iteration. In terms of accuracy, recall, and running time, 0.9 is the best choice for the parameter alpha, where the take power is strong weak. Here is the figure for the determination of parameter alpha. The left part represents the case with the weak power. The right case represents the case with strong power. The horizon vertex represents the parameter alpha. The vertical axis represents the corresponding indicators. You can see the indicators of max called RXA is similar to max called RFA when parameter alpha takes the value of 0.7. We can also check that no matter the attack power is weak or strong, 0.9 is a good choice according to the precision, recall, and running time. Next, let's make comparison between these algorithms. The simulated block digit data set includes 10,000 blocks. The block generation rate is 10 blocks per second. With the increase of parameter d, the precision of these algorithms is gradually decreasing. The index of recall has little change, especially when the attack power is weak. The recall is basically 1. When the attack power is really weak, the results of max called greedy and max called exact are basically the same. When the max called exact is better than max called IFA in the index of recall and almost the same in the index of precision. Here is the results of the 3 algorithms. Left part represents the case with weak computation, weak attack power. We can check that from the aspect of the indicator precision, there's nearly no difference. From perspective of the indicator recall, there is a little bit difference, but the difference is not very huge. As for the case with the strong attack power, the impact of parameter d on max called exact is much greater than that of max called IFA. It can be said that max called IFA is more robust. In terms of precision recall, max called IFA is better than max called exact, and max called greedy is the worst algorithm. The right side represents the case with strong attack power. We can see that there is much difference. There's much more difference than the left side. So the 2 indicators, it can be said that the green algorithm, which represents the max called grade, is the worst. The blue part, which represents max called IFA, is well robust to the parameter d. Max called IFA is the best algorithm for deal with the honest block identification. Next, we propose another honest block identification framework. It's especially for the hybrid blockchain system. First, we need to introduce the hybrid blockchain system. For the hybrid blockchain system, there are two kinds of nodes in the system. One part is authenticated nodes, the other is non-authenticated nodes. The authenticated nodes here are usually institutions or individuals with high reputation, such as national institutions or large well-known enterprise. The real identity of these nodes needs to be authenticated before they can join the system. there is the possibility of doing well by these nodes is far less than that of the ordinary nodes. So, as for the framework of honest block identification for the hybrid blockchain system, it contains two parts. In the first step, based on blocks generated by the authentication node, the set of blocks in the blocks generated by authentication node is identified by mascot method. Here is the mathematical programming for the first problem. We mainly solve the maximum independent set for the blocks generated by the authentication node. In the second step, the honest blocks in the whole block DAG network are identified by limiting the inclusion of honest block calculated in the first step. Here is the mathematical programming for the second step. Actually, the framework for the honest block identification for the hybrid blockchain system is transformed to the maximum independent set with the known set. Next, let's look at the results of the honest block identification framework for hybrid blockchain system. We use MRS maximum independent set for the identification result of mascot. MRSS maximum independent set, including known set for the identification result in the hybrid blockchain system. Here, the central represents the number of authentication nodes in the whole blockchain system. In our simulation results, we assume that there are 10,000 nodes in the network, and the block generation rate is 1/600 blocks per second. The results show that even if the attack power is relatively high, reaching more than half, the precision of honest block identification algorithm in this section is relatively high, close to unity. At this time, the precision of honest block identification by using only mascot is almost zero. Even when the number of authentication nodes is low, only 0.9, the attack power reaches 0.7. The precision is considerable. Also, the addition of blocks generated by the authentication nodes can greatly improve the precision of honest blocks identification and ensure the security of the blockchain system. Here's a figure to prove the results of the honest block identification algorithm for the hybrid blockchain system. We can see that the precision of MRS is always better than that of MRSS. No matter, even if the attack power is quite strong, for example, reaching 0.7, 0.8. We can also look at the fourth figure, when the case in which the central path is 10. There are 10 authenticated nodes in the blockchain system. Even if the attack power is 0.7, the precision of MRSS is also better than that of MRS. Okay, let's come to the fourth part, conclusions. Aiming at the efficient blockchain network based on DAG, algorithm framework of honest block identification is proposed, which is conductive to the subsequent solution of a block sorting problem based on the results of honest block identification. In this way, block DAG can improve efficiency on the premise of ensuring security. At last, I want to thank Professor Wu Lingyun's guidance for this research. Thank you.
Oh, thank you. Thanks for the talk. And just now, Xu Wang give the talk directly, and I still want to introduce Xu briefly. Xu Wang is a postdoc fellow now in Tsinghua University, and before this, he received a PhD degree in Operations Research and Cybernetics from Chinese Academy of Science in 2020. This also gave a special perspective for him to look at the issue in blockchain. Come back to the talk. Here is a question from the audience. When you compare the three algorithms, you mentioned the attack power. So the problem is, what's the boundary between the weak and the strong attack power?
Okay. In this research, we briefly choose the threshold 0.5 as a boundary to differentiate the case with the weak power and the strong power. As for the simulation results in this research, the case with the weak power, we choose the attack power of attack nodes occupy 0.3 in the whole system. As for the case with the strong power, the attack power occupies 0.7 in the research.
Okay, thank you. Is there more question?
可以。
中文问都行。就是我想问题就是不知道 DAG 里它的攻击就是攻击者的。就是它这个不知道 DAG 里它的攻击者，它是有那种几种攻击模式，因为它好像和就是传统的那种单链模式的攻击方式不太一样。
对，是的。In this report, we mainly focus on the double spending attack. You can check the illustration. You can see there are two red blocks in the illustration, blocks 5 and 6. If there are two conflict transactions in these two blocks, without the mention, we can't know which one is in fact. So as for the double spending attack, we need to get the total ordering of the blocks to deal with the double spending attack.
So in the experiment, you use the attacker's power that to randomly take the double spending attack in this.
Yes.
Oh,
Okay. Thanks again for the talk.